Eagle has landed. That's another book. That's did you read that book by Jan? What's the guy? Is Irish?
Ready to begin.
Okay. Hi, everybody. So, what's the situation on how many people know the answer to the secret code? If anybody, you got Kathy, you and your team.
Not the first.
What?
I have the solution to the second one, but not the first.
The second one.
I haven't had time to go through the first one yet. The program's working.
But you have programs that were able to help you with the second, or did you do it all by hand?
No.
And Anil, you claim to have.
I had both of them.
Okay. So now are other people? Everybody's studying for the comp. Is that right? There's a little exam coming up on Saturday. The last exam, it's Sunday. You're right. The last exam of your life, you might as well enjoy it while you have it.
What about the call?
That's not exactly an exam. Well, it's sort of like it, yeah, right. But okay. So I understand that your sympathies aren't entirely 100% with this course today. Is that right? But do you have teams anyway? Somehow, you guys are all okay. Now, the thing I wanted to talk about mostly today is the idea of interaction. I think we those of you who have solved it, and maybe even those who haven't solved it, will realize the need for interaction in a problem like this. The machine, I don't think we would take a machine that would come up and say, I've solved this problem, unless the machine somehow knows something about how to distinguish solutions from non-solutions the way people do. And there are probably zillions of solutions. I don't want to estimate how many there are really, but I think only one, as you see. Andy might still not agree, but as of last week. But I really believe there's a unique solution to these cryptograms, but only because it has to make sense after. So therefore, a human being has to be in the loop. Now, but what are going to be good ways to have a human being in this loop? I mean, a human being is going to be there to evaluate things and maybe suggest directions. But what should the person be doing? So let me get some ideas on this from the people who haven't solved it yet, and also from those who have, and we'll see if they maybe are the same or different. What do you think? I'll start counterclockwise. Pang. Who are you working with?
I'm working with Arif and Dimitri.
Okay.
And so far we're on the design stage of the program.
You mean you're studying for the comp? What are you designing? So you're trying to design a program that would do what kind of things?
That would produce some output. I mean, it's sort of like playing hangman. And you have all the you assume, to say a string is probably at this position, and you put it in and see if it works. And if it works, then
okay. So you have a conjectured string and a conjectured position,
yes.
And then you have a program that puts it in and sees if it works.
Yeah.
Okay.
Well,
that's interesting that you brought up hangman. One of the problems that I considered having for this class was to find the hardest word in hangman, use a dictionary of English language and try to figure out which would, in some sense, be the most difficult hangman word. And I thought it would probably come out to some three-letter word with different unusual letters, but it wouldn't be. But anyway, it might still turn out to be an interesting problem for another 204 someday. But this is but hangman is a guessing game where I see you get partial. It'll say that some of the letters are in there and the rest of them are still unknown, and here we have 256 unknowns, and some things are going to flash in and say, oh yes, here's one. Yeah, I see. It's a similar idea. Okay, so now the first question then about this the position of the string and so on. And how are you going to present this information? You got 256 characters, some of which are known and some of which are unknown. How do you tell the user in an effective way? Well, how does the user figure out what position? Does he say, is it in position number 137? And if so, how did he know that? How did this number 137? Did he sit there and count up to 137, or how does the user specify a position? Have you worked on that at all in your group? Arif?
Just that tries out all the places which have not yet been tested out. I mean, all the places where it could fit in. It gives you all the places at which it could fit. Okay. And displays the corresponding transformation which will happen. I mean, the resulting partial passage.
So suppose it fits in 5 ways. It gives you 5. In other words, so you specify a word like program, and it says program could occur in these 5 places.
That's right.
And then what else do you show then?
And it shows the partial passages which result from making the partial substitution for f.
Oh, I see. So you'll have, let's say in the case that program occurs in 5 ways, you would have 5 examples where one of them would say program here, and it might also say it might also say
a lot of
9 something, right? And then this one might say program here, and it might say right curly brace Q exclamation point or something, and so on. Each one would put program in there and also other consequences as well as everything else you've assumed. Okay, right? So now, and what if there are 80 of these instead of 5 of them?
Then you forget about the word and try another.
You forget. Oh, I see. There's too many. Okay.
If your tree is too large, and you can't prune it to a smaller size, then the word is a bad choice for.
Well, maybe the word occurs a lot. No, okay.
I mean, if you can prune it, for instance, you have curly bracket Q exclamation mark.
Right.
Okay, and that is a very unlikely thing.
Yeah.
Okay. So you could probably drop out that one, but after doing that, if you're still left with 80.
Okay, so yeah. Now, so yeah. After that, if still left with 80, then you wouldn't want to even try one. You would go ahead and try a better word. Okay. Now, but it's a little bit like a search in a database in library, for example, where you say give me all titles of papers that include the word program in them, and then the library it'll say I found 1,384 references, and so then you say okay, let me refine that, and it should also have the word structure or something in it, and then you get down to something where you can list them all, or like the news service program or something like that, where we have so it's in a way where we have a lot of data inside the computer, and it'll present till finally there's a small number of things that a person can look at. So then he doesn't have to know that this is in position 100 and whatever I said, 139. Wherever I got
the
that
slight
number.
difference about the point is that over here you don't know what other words should be in the thing. You are just making in the first place. If a program, it has to be there. But let's say you guess that while is there. You are not certain it's there anyway.
That's right.
Okay.
While, okay, or right. Begin is another one. It's got to be there.
Begin, end. Okay, these. But beyond that,
right.
Very few things which are certain.
Okay. So anyway, then a person can just say the third one or something like that, or how is that the way you want to?
Then you pick out one of them and sort of do a depth first search from that.
Now let's talk about what that. So then now it's you're thinking of this as a tree, and here was something where we had nothing known, and then we might have 5 branches that are displayed there, and a person says, let's look at this one and try to explore that. Okay. And then they're back, and then they're at a situation where like a person types in 3 and they see, okay, here you are, now it says what's your next keyword? Is that right?
Those aren't necessarily disjoint paths or branches.
They aren't necessarily disjoint, okay. And what do you mean disjoint? That is that it might be true that program appears more than once. Is that what you mean?
For example, program might appear more than once. If any word appears more than once that you're searching for, you'll get two of those, and they may both be consistent with each other. In fact, they might
be consistent, right? So the fact is that in fact, well, let me take suppose that you said program A was your keyword, program space A was your keyword, and it found maybe that program space A could occur in different places in there, and you might go down the tree a long ways, and you might find consistency, although really the true message says program B, but program A doesn't look inconsistent at the moment. So it's possible for you to actually go down the tree with things that are consistent and the final message, and really you'll be wrong. But you'll still be able to decode a great amount of message even though there's something wrong in there. Do you see what I mean? Because A and B, that's only off by one little small part of F, and that might not propagate. Some parts of F seem to propagate to large parts of the message, and other parts are fairly easy to twiddle and change since they won't harm anything else. So in this tree, even the user can imagine probably that he's going down one branch, but it doesn't necessarily mean that the other branches are wrong, or that the branch that you're on is right. But probably as a model, as if they were disjoint. Well, what harm is there if you assume that they're? I mean, if you pretend like they're disjoint and just continue on and keep exploring as if they were disjoint. I'm not quite sure why non-disjointness is a consideration in writing the program.
No, I didn't mean it in that sense. I meant that you can't, if you choose one of those paths, in fact, several of those paths may correspond to the same eventual message.
Mm-hmm.
And
that's true.
That's always true.
Only if the word appears several times, which is conceivable. If you have a common word like the, it might occur a lot. I tried once. One of the things I tried this just a keyword of space, single letter space. See, and I had 90 some places I could put a space, so it didn't help much. But I just wanted to try it to see. And then in fact, I did have the machine construct an example by putting in as many spaces as it could, and then I put in as many E's and then T's. I went in the order of frequency of letters in English text, and just to get a message that would sort of be the most probable in some blind sense of single letter frequencies. Okay, so now Dimitri, is there anything else that I'm missing in this design here? And so the idea for this is then one of the aspects of the interaction will be then to be presented with the partial solution so far, and then it's time for the user to type a keyword, and the keyword, and then we display the possible choices to go from that keyword. How do you display this message as far as the other places that are still unknown?
I put underscores.
Well, let me ask Dimitri, as long as you guys are all working together, how do you think?
We use some other fictitious character like underscore.
Some what character?
Underscore.
Yeah. What was the first? Some
character that is not used in our message.
No. Oh, okay. So you found a character that was sort of indicating no, that you would use for representing the other, like underscore, and we assume that the message doesn't have too many underscores in it. For example, Pascal programs theoretically don't have underscores in them, and neither do English texts very often, although it's an ASCII character. Okay, so underscore was a fairly I guess it's even the way we used to play hangman when we were kids, is we put underscores in place of the unknown letters. What about what if you find a carriage return? How do you indicate that? How does the user know that you found a carriage return in a certain place?
So far, I don't think we have covered this. That one, but we so far just write out
The message was what?
CHR 13 or whatever. So
Oh, I see. Chur 13.
I don't know what it does in that case. Maybe it prints out carriage return in angular brackets or something. I don't know.
see. It might blow the fuse. You don't know. Oh, I see. In other words, Pascal. In other words, it's not writing out the letter. You're just saying Chur 13 in this, and this probably does return the carriage, and so does and null would just disappear entirely, probably. Chur 0, huh? Okay. What do people think about that? We got to represent. We got to represent more than. We've got 94 visible symbols and a space, and 3 others that could be in the message, according to ASCII code anyway. But we have 90. So that's but we actually have 94 plus space and 3 others plus not yet known. So that's 94. So we have 4 other things to display to the user. Then we have symbols available to us for display. So
the way my program handles it is it uses two letters to display each letter. So if you've worked out a letter, it'll be displayed as space. For example, if you worked out program, it'll be space P. Okay. And return is carriage return, which is the 13 is /R. New line is /N. Backslash
N. And what is the unknown?
And the unknown is done as a left curly brace followed by a right curly brace.
Okay, so in other words, you're sitting here with something like this, and then P/R/O/R, something like that. If somebody put a carriage return in the middle of a program,
and null is /0.
Okay, so you made up a 2-letter code that would give you this, and since you're one of the people who solved at least problem 2, it must have been visually acceptable to see patterns that
I have an example of what it looks like.
Spread out. Oh, you do? Okay, well, let's put it on the screen.
I'll
wait a minute. Do it early.
We'll give away the answer. It's not a good idea.
Oh, what about the very first step?
It doesn't have carriage return in it. or anything interesting.
Well, okay. I think let me look at it and censor it. See if I can.
That's not a complete run anyway because I ran out of disk space.
Okay. You ran out of disk space?
Yeah.
Okay. You've heard about the solution to that problem, right? We've got accounts for everybody who tells
it was
Ramsey.
my fault.
Okay.
I had these files that I deleted which I hadn't cleaned up after.
Well, that's still there's some people are operating with limited accounts that are supposed to be good enough for mail but not good enough for solving cryptograms, and so you should tell Ramsey immediately, and then you get more, you get a better account. Okay, now I would like to show at least the beginning of this. Just so that you could see that this two-letter thing actually doesn't seem to be a hindrance. Let's Ramsey, cover up the bottom part of the sheet, but just leave the first two on there. Why not? I'll warm this guy up too. Okay, now. So the question of presentation, by the way, I is it going to be clear when a person sees a lot of these where the keyword is? I mean, if this were being written, if we had a Macintosh or something, we would highlight this. We would highlight these words, but we're writing a program in programming language that was not where our output statements don't give us a convenient way to flash the screen or whatever it is, because those languages were designed before there was much hardware that would do these things. Karen, you have a comment?
Well, it's kind of our hypothesis that if we're trying to optimize on the total time taken from the start of solving this problem to the time when you say, eureka or whatever, that the display will be a really crucial feature of it. The ease with which, the user can look at this display and make guesses and see patterns. That basically anything you can do to make it easier will be very important in the total.
Okay, that's the critical. Yeah, the critical thing is to somehow get through so that the user doesn't have to do too much translation. It sort of feels like a joystick or something where you can just say, okay, go there, go like this.
But that's even more important than super powerful commands, and so.
Well, we can argue about that one, but that's okay.
Right. This is our hypothesis.
Yeah.
But so we were going to try to use one of the packages to get reverse video and Rich and John.
Okay. Reverse video.
Right. To do some of that kind of thing. That it would be sort of worth the effort.
So what programming language are you working on?
Well, this is
Pascal and C.
Yeah.
Pascal and C?
Yeah.
So, and you're working on Score or on Baxis? On Navajo? So, you got an easy way to get reverse video on?
Well, there's a cursive package.
There's a what?
A package called cursives, which does screen manipulation.
Okay.
Terminal independent?
Yeah. So you have a terminal independent screen thing. So see, I've never had a chance to use a package like that, and I began to feel the need for it only when I work on a program like this, which needs a lot of interaction. Otherwise, a lot of the things I do are, I'm happy to just get ordinary old printouts. But just for exactly the reasons that Karen says, I want to have something that'll focus my eyes on the right place and not have to spend a lot of time figuring out what to do. That was a problem. Now, see, this thing still doesn't look on. Oh, okay. And so, for example, I was working on Sail, and I think I used equivalence sign for the unknown characters, just one at a time, and then I had to use something like a unequal sign for null, because we got a large character set on Sail, but we don't have an easy way to flash characters.
Ultimately,
by the way, Dennis told me that he would have this camera only hooked up to that. It wouldn't be hooked up to the main. Would never show me on here, for example, but we might try this to see if we get infinite. Oh, wait a minute! Can somebody see a screen and a screen and a screen? Okay. So anyway, here's an example then of how Kathy's program looks with the left and right curly braces for nulls, and with program. Look at that! She found program right at the beginning. Is that a surprise to anybody? We're giving this away.
That was the program that finds program at the beginning.
Excuse me?
That was the program which finds that word. You say you want to guess a word, and it goes through its table of words and their and letter pair distances. Okay.
It says distance 12 here, so yeah.
Oh yeah. The first thing it does is reads a file of words and calculates interletter distances. And then it uses that when you say get, when you type G, which means guess, it uses that to look to see whether it can fit any of the words in its table into the cipher. Okay.
Okay. Well, let's go back and talk about that later, because that's another issue that I want to sort of try to keep one thing on the table at a time. Yeah. So the main thing there is you have printed a grid here along the top, though, going 0, 1, 2, 3, 4, and 0, 32, 64, 224. What's the function of that?
That tells you the place, that allows you to calculate the number, like you can say, if you want to add a letter, you can say exactly where you want to add it in the cipher. So you might guess that the letter after the M will have to be a space, and so you can say, okay, from that you can calculate that that's number 7.
Okay.
In the grid.
Now let's so you don't have a mouse, for example.
No, it would be nice.
that just points to the place, or a touch screen or something. Yeah. And I guess I should just wanted to give my 30 seconds spiel about wondering how long it will be before things are standardized enough that we could assume some kind of normal conventions in many programming languages without having everybody on every different machine having some other way of doing it, because of course we have so many different machines, and this is probably going to be one of the last things in programming languages that gets solidified. Even the I/O that we have now took another 10 years after the rest of the programming languages were fairly well understood. I was chairman of a committee in 1963 where I remember somebody on the committee was saying, we can't come up with any standards for input-output because nobody understands input-output yet now, and I said to the other people on the committee, well, look, we've been looking at these problems for 5 years. By now we certainly understand more than we did 5 years ago, and we're ready to go and finalize it now. That's what I thought was true in 1963. Well, things are still up in the air in 1985. In fact, some of you weren't born in 1963. Is this true? No, I guess maybe all of you were almost born in 1963. Right? Conceived anyway. And there might then once this gets solidified, something else will come along. But for a while, but somehow there's this dichotomy between the people who think that input-output isn't part of real programming, and those who think that it's the only thing real and so on. And it's because it depends so much on hardware that we think is developing fast. We can't get a handle on it. We can't really make a decent long-term prediction about what's the right kind of a standard to decide on once and for all. On the other hand, we sort of agree that plus sign should stand for addition and things like that. That's much more stable. Okay, now let's see. On this thing then, it does seem that the two-letter presentation is not really a hindrance as far as recognition is concerned. Having spaces between the letters doesn't look distracting to me unless I had a message with a lot of spaces in it, where it might be hard for me to track spaces. But presumably that's not that would be the only defect I could think of in something like this. Notice that some other things flashed in here. This looks like a left parenthesis. This must be a right parenthesis, and a letter and a 9 came in. Those were implied by putting 7-letter program into the thing, I guess. So, at least this is a way of getting around the fact that you don't have enough characters. If you go one character per character, you don't have enough characters to display all the possible data. The other approach that people said was that, well, some of those ASCII characters we know because of properties of Pascal, we know that they aren't in the program. Pascal was invented for a 64-character machine, after all, so it has to be possible to write Pascal programs without it. Although I could have been sneakier and made it capital P-R-O-G-R-A-M. It didn't occur to me until last week that I should have done that.
In some cases, middle.
What?
Or switched cases.
Switched cases in the middle? Yeah, right. Program, yeah, right. This is the opposite of an anti-gram, you know, you could have. So in fact, it looks like I used lowercase p there, didn't I? And maybe it would have been harder for people to do it because it's more convenient for us usually to type on our terminals now with lowercase. All right, so English text also doesn't use all of the characters that are involved there. There's not very many novels that have backslashes in them, and except user manuals for typesetting systems. But one of the other big needs is to have a few more visible characters that nobody uses, just for purposes of display, things like this. I think it's an interesting issue that when we start talking about text as text, and sort of computer scientists dealing with things at a meta level, one level over, every character that we have that isn't commonly used in the text that our programs deal with, every such meta character is a treasure. And we, the fact that we have these a backslash, and we have some at sign or left string quote or something that's not on a typewriter. At signs are on a typewriter. Sometimes you get square brackets that are in programming languages and not even on IBM terminals, I guess. But every new character that we can display, but doesn't appear in the kind of text that we're doing, seems to be extremely valuable once in a while. And if that had only been realized by the people who designed these standard character sets, that a few more characters could really help in designing systems. I have in the tech program people using this in all different countries, and they have different languages for their alphabets. Russian language has 32 letters in the alphabet instead of 26. The Norwegian language has 29 characters. Norwegian, Danish, Swedish have. And they have to go into these extra characters like backslash and so on that we use for delimiters, and they don't even have that. They don't even have those because they're taken up by letters in those systems. So for presentation of information, extra enhanced character sets seem to be helpful, and one way of getting around it is by going to two characters at a time, I guess. Any other ideas on how to present this partial solution of a message? Okay.
I think we were going to try 2 columns for each one so that adjacent letters would be next to each other.
2 columns?
Or 2 rows.
2 rows, sorry, so that a single character would be represented by a little column.
Okay, I don't get it. Oh, I see. Oh, okay, I see. You would have a carriage return indicated by maybe a C, a C over an R or something like that on a 2-line notation.
Right.
Okay. And, yeah. Oh, okay. That's another good idea. I think it's so an emphasis on this kind of visual that corresponds with our whatever it is cortex, and something that'll flash in well is an important part of a good design, I think, for an interactive program. These 2-line notations are interesting from that I guess the very first programming language in history, the plan calcul of Konrad Zuse, was a 4-line. He had all the inputs on 4 lines, and you would have to write your program on 4 lines. These multi-line things have been are difficult on input systems, I think, but for output display it can be useful. The program that I use for inputting musical notation now has you give every line of music on several lines will specify rhythm with on one line and pitch on another and things like that. Well, now what about, let's go. Oh, I'm sorry. I was coming back to that, you guys, just after you, because the other thing I wanted to talk about Kathy's program was to these numbers on there for referring, because she had this idea that she wanted to be able to essentially point to a place in the message and say, now let's try putting a comma there, or try putting something, a space at a particular place. And I would like to talk about that. So let's take a look at this beginning thing. And suppose I wanted to try. See, there's a 9 there. Suppose I wanted to put a semicolon right after that 9. What do I do?
You would type A for the add command, and then on the next line and then you type return, and on the next line it would say which character do you want to add. Now you've got a choice. You can either type a semicolon then return, or if you wanted something like a null, you put slash then the number in decimal.
Okay.
So that way you can put in a carriage return and be sure of getting a carriage return or whatever.
Okay. So I have some way of specifying that it's a semicolon. Okay.
Yeah. And then next line it'd say whereabouts do you want to put it, and you just type a number. Okay, which means you have to add, for example, you'd have to add 224 to something if you wanted to put something on the bottom.
Okay, that's what. Yeah. Okay. So now, by the way, I forgot to ask you, Kathy, who are you working with?
I'm working with Marianne. She wrote the first part of the program to go through the words and find letter pairs.
Okay. You didn't work together on the first problem, did you? You worked the other way around. You're another. No. No. No.
I was working with Karen and Anil.
Oh, that's okay. I just wanted to try to keep also moving people around too. Okay, so now you have to add 32 to 19.
Yeah, it's
and if that's easy for you, then you just say 51. But if it's okay. Now, is there a way that addition could be speeded up? That's the issue I wanted to raise, according to what Karen said. Is there an easier way to point?
Yes.
You could make it a matrix, or if you're just using a printout like that, you can make it a matrix of whatever by whatever.
Or I could just make it so you're adding something which is a multiple of 10, because that's a lot easier.
That's a lot easier. Yeah. So here we've got 32 in a line.
If it was just 30, it would be easier.
If it was 30, it would be easier. Yeah.
You could do it like Battleship.
You could do it like Battleship. What's Battleship, Randy? What is the Battleship?
You have letters down one way.
Specify the coordinates.
Okay.
I could just specify coordinates. Yeah.
The chess international FIDE way of writing chess moves. Okay. So
another way of doing it would be like in an editor. You actually sort of keep giving spaces until you come to the position, spaces of some whatever character you have for going forward. Let's say Control F in.
So you would have a cursor.
You'd have to have that.
You'd have to have a cursor.
That would make the program significantly more complicated. I tried to make this fairly simple. I didn't want to spend all my time on it.
Yeah. Before I wanted to try some. So a week from Monday is when a week from Tuesday is when we want to demonstrate all these programs by solving ciphers as a group here, and I want to have some kind of a computer in class on Tuesday so that we can look for bugs in that installation beforehand. And I'd like to try to work out by then how easy it is to get some of these like the curses things if it's going to be possible to see it in this sub-basement room where we are now. So we'll try to shake out bugs of that kind, but next week, just so that we can have something to display on the screen, and then we'll have the real problem-solving session a week from then.
Actually, I think there's a fairly painless way to do this, but I'm not quite sure if it works, which is Emacs allows you to build your own commands. So you could, basically edit your crypt file and write little Emacs commands to search for words and stuff, which would call your own routines.
So you'd be running Emacs at the same time as...
Yeah, Emacs would be the top level, and it would be calling your lower level routines.
Wouldn't you have to write it in teacup?
No. First of all, you use Emacs, so you'd endless. But I think endless allows you to call this. I'm not quite sure. That's a part of it.
Okay. Yeah. So that would be a way of getting cursor in there, and then you would find your position by twiddling keys quickly instead of by saying row and column coordinates. That's okay. So that's a way of pointing with a keyboard instead of with your finger or a mouse. Yeah. And then, but if you have coordinates, something that minimizes the need for mental addition is useful. And did you also have? Can we go back to that one again? Did you also have? Okay. Now, another thing is, I would recommend if you have something like this, you could print out something on the right-hand side in the bottom as well as on the left-hand side in the top, yeah. Because the farther away you get over here, the harder it is to see what line you're in, and
I only put that grid on it this morning. Okay.
Yeah.
Last night when I decoded it, I did it without the grid.
Without the
grid.
Really
horrible.
Yeah. Well, I must confess, the way I did mine, I had it would show places where I could hit. So instead of displaying programming this way, I would have one. It would show the entire thing, and then I had a special character that would go in 5 places in the message, and those would be the places that I could put the word, and then I would just say choose the third of those or something like that. But if there were 20 of them and I was choosing the 17th, I would have to really go through and make sure that there were just exactly 3 after it or something like that. Okay, I miscounted a few times, but it did take me. I mean, consciously, I had to sit there and that's taking time. If I did it wrong, then I could always back up and do it again. But as you get to working with a program, you'll see these ideas will, I think, come spontaneously that don't occur to you when you're first designing it. And this is one of the reasons why I think you have to live with any interactive system before you have any confidence at all that you've got the right one. You can't just do these things on paper, and this is something to keep in mind when people say that never write a program until you've specified it completely. This has to be tempered with the fact is that when you're living with a program, you think of new specifications constantly. Even a program like Tech, for example, that I kept record of all the changes I made to it over a long period of time, and for a period of 4 months, I would get one new idea for how to improve Tech every 2 days. It was a sort of a steady. No, sorry, every 2 pages. It was over some. This was not over. I didn't get to work on the program constantly. But I was entering volume 2 throughout the time, so I calibrated the x-axis of my scale was how many pages I had typed in of volume 2 of my book, and then every 2 pages I would get another idea how Tech could have been better to handle it, and this kept on going steady until I had typed up about 500 pages, and then on the last 100 I didn't get any new ideas at all. But for a long period of time, over a several months period, every time I would start out in the morning, I would think, yeah, now Tech is complete. There's nothing more to do because I now have a system that I want. And then 2 pages later, I'd think of something that was a big improvement, and this went on and on. Okay, and so with interactive system, I think that's also typical. Like Kathy said, she just added something this morning, and you keep thinking of more things to add too, the more you live with interactive thing. And I guess another moral of that is that if you're the designer and the programmer but not the user, you might not come up with the best system, because it's while you're sitting there working with the system that you think of these things. It's not when you're off in another designing tower that you think of them. It's when you're actually sitting there using them. So it's system for interaction. I think the designer and user have to be the same person in order to do a good one. Anybody want to challenge any of these things I'm saying or add more? Just speak up. Now, let's see. Then the next question is, I guess I promised to come back to what you were saying, that you have a different way of going at it than you had a G command on your thing. As long as we have this to display, we might as well milk it for all it's worth. Can we get this back on here again? Now, at the beginning it says type H or question mark for help. Now what? This is, types H or question mark for help. That's always makes it seem friendly, I guess. What if you type exclamation point? What?
So I didn't forget these one-letter commands. I mean, it's easy to forget what.
Yeah. Oh, okay. Yeah, that's right. There are one-letter commands. So what if you type exclamation point?
It will wait until you type something which is a valid command.
Okay.
So if you type exclamation mark,
now what?
you'll
You'll say now what? Oh, okay. Type extra. Okay. So okay.
Okay.
Anyway, there's all kinds of ways to interact. But if somebody says G, well, this was, and there was distance equals 12. So let's go into algorithm mode now for discussion. What does distance equals 12 mean?
That was left over from the output from Marianne's part of the program, which at the moment still writes out. I haven't got rid of that output yet.
But what does it mean?
What it means is these are all the words which have two letters which are 12 apart.
Oh.
Okay, and there are no words there.
So I'm sorry. You've listed. Yeah, Marianne.
I made kind of a dictionary of all the Pascal keywords. And
I see. Let me see that.
So this is the list of all the Pascal keywords.
Right. Program and const, else, forward, and so on.
Yeah. Other words that are more than two letters.
Where did you get this list? Just by looking at the manual?
Pascal manual.
Okay. Because, no, I mean, the president would have forward in there because it's left out of the index of the most Pascal books somehow or other. External isn't in here. Okay. Yeah, okay.
Then I ran a program on that file that would search all the words that have the special property we mentioned last time.
Okay.
That is
a distance of, for program it would have a distance of 5, for example.
Oh, yeah, exactly. Mm-hmm. So this is the output that I got on this.
Oh, okay. So in other words, it starts out and it says distance equals, oh, I see, that's just left over. That's not distance equals 12 does not mean that we're now sitting at a situation which we're 12 steps from the end or something like that. Okay. For example, an output, it turns out to be a very good one because it has 2 uts in it. Is that right? Okay, well, yeah, I guess output is a normal way to get output. It has 2 uts in it, and input has an ut in it also, and then those are distance 1. Pact has a distance 1 ed, function has an on, procedure has an ed, and const has an on. So and then there were at distance 5 program was the longest such hit.
Yes.
Okay, function has another one. Okay, so that's an interesting list. So that's what that's left over from. Yeah. Okay. Now then, okay, so that program has run, and then now what? And it says G.
Well, I typed G.
And you typed G.
Yeah.
And that means go for it.
Well, yeah, I guess so.
Go for what?
that means Start from the beginning of the file and start from the beginning of the cipher, and look for letters which are however many. Look for letter pairs anyway which are less than 12 apart. So first of all, it starts at the first letter and sees if the one next to it is only one apart.
Okay, so no, you're looking for two places where you've got CK plus K equal to each other that are that are a certain distance apart.
Yeah, that's right.
Okay.
And then it tries. Once it finds a possibility, it tries it and writes out the cipher, which is the cipher text that it gets, which is what you see on the screen there.
So this is the first one that it found.
Yeah, that's right.
Okay.
Okay, because there are no distance 2 or distance 3 ones in that word. And anyway. Okay, then it says, do you want to?
But it didn't find it. Wait a minute. There were distance 1 words though. How come it?
No, it starts at the height. It starts at the beginning of the cipher, and looks for all.
Oh, at the beginning of the cipher. Okay.
Yeah. Okay.
All right. So this is so from starting at the beginning and going toward the end. That's why I found this one, because this is the first.
It's the first one
coincidence of any kind.
That's right.
And
yes.
And maybe that's the same reason Mike noticed it too.
Could be.
Okay, last week. So there we are.
Right. Then it asks you if that looks okay. So when it finds a word, it prints it out so you can see if it's put anything strange in it. It already checks to see if it would write any invisible characters or anything nasty.
Right. It wouldn't even put that in at all.
If there was a control, if it mapped something to a control D or something like that, it wouldn't even bother displaying the.
Some illegal character, then they wouldn't even consider this as a live possibility.
That's right. So it's already checked that, and then you have to look for anything which seems like strange Pascal syntax or something like that. So, for example, if it wrote a plus sign straight after the M in program, then you'd think that was a bit strange, and you'd probably say no.
Plus, right.
Okay.
All right. Okay. Right. Or after or left. Yeah. Anything can go in comments, but yeah. Right.
Yeah.
That's right. In fact, so there are, as you're decoding a message, you get things that seem implausible, and some things that seem definitely wrong to you. But I guess there's sort of the same idea. Like when I was solving my wife's, the one that my wife presented to me, I thought I was fairly well along with the solution, but all of a sudden here pops up a 5-letter word starting with capital H-A-Y. And I said, now wait a minute, I must have made some terrible mistake. I couldn't think of any mistakes though on the other parts of the message, but here's this capital H-A-Y sitting in there, and so I thought certainly I would, I'll find some problem there. Well, 10 minutes later I realized it was Haydn. And then Vivaldi fell right into place, and I knew that the whole subject of her message was music and things like this. But sometimes there'll be patterns that don't look correct that turn out later to be others that don't look correct and really aren't. And that's the latter is usually the case.
Well, you.
And I said, now wait a minute, I must have made some terrible mistake. I couldn't think of any mistakes though on the other parts of the message, but here's this capital H-A-Y sitting in there, and so I thought certainly I would, I'll find some problem there. Well, 10 minutes later I realized it was Haydn. And then Vivaldi fell right into place, and I knew that the whole subject of her message was music and things like this. But sometimes there'll be patterns that don't look correct that turn out later to be others that don't look correct and really aren't. And that's the latter is usually the case.
Well, there is a facility you can undo. You can undo single.
Okay. Now it says, do you want to undo this? So yes. Yes, no, and so now undoing means what? Just go back one step.
Go back to the map you had before you tried putting that word in, and
okay.
and sort of and then ask you what else you want to do.
So map is the F function that
that's right.
that you have, and so at every step you have a certain map and you have a previous map. How do you go back to the previous one?
I have 2 copies. It's not very nice, right?
Just 2 copies?
Yeah, I have 2.
You mean if you undo twice?
If you want to undo, once you've got that word there, if you don't undo it at this stage, the only way you can undo it is by undoing single characters at the moment. This is only. This seems acceptable for.
It's a starting point. Yeah.
Yeah. I mean, at least it lets you get somewhere. It lets you decode.
Okay. So there is a, but no, I'm not asking you to defend your program now as being the final thing, but I just wanted to raise the issue of undoing and so on. So the same thing occurs in the solution that we were talking about earlier. We start to walk down the tree, and we'll get to, we'll make a few choices, and we'll want to finally we'll get to a point that doesn't look like it was the right choice, and so now in general that the backtracking or undoing to get us back to a previous situation. I was wondering if people had thoughts on good way to handle this. For example, you could store the entire contents of your computer memory at every level, and then read it in again from a file. If you have this backing up procedure. Or the question is, how much do we really need to save at each point? What's a good way to save it? The question of undoing is primarily a data structure problem, it seems to me. As we go through any problem that has a chance of backtracking and going and taking back something that we've done, we either have to store all of our forward motions in some reversible fashion, or else keep some at checkpoints enough information to reconstruct the whole state of whatever is needed in our program at some point. So what are people's ideas on this, for this kind of thing? Let's see, I'll get to, maybe I'll bring some more people on. Let's see, Karen, you've spoken, Rich, you're together. Dimitri, Andy. I got 2 Andys in a row here. Who do you want? Who should I pick on? I'll pick Andy. You're smiling, so pick on me.
Well, I guess probably the simplest thing to do is, as you said, just store the checkpoints and also store the commands that lead from one point, from one node to the next.
So, for example, these are our checkpoints, level 0, level 1, level 2.
Well, you don't have to make them every single level, but...
Oh, I see. At certain levels.
Yeah. You could store logical dependencies of how everything was derived, what everything needed to get derived, and then you could actually undo.
Okay, now that's very abstract. Let's talk about concrete, for example. What would I store at a place? Suppose I move to this, to adopt this solution. What would I store here? Would I store the current contents of the plain text, the current contents of F, the current
the contents of F, I think, should do it. It depends if your program is doing some automatic processing. Like, if you say one thing and it produces lots of logical consequences, then it has to remember that those logical consequences were caused by that move.
Right.
So when you undo the move, it undoes the consequences.
Oh. Well, okay, so we get consequences of a move that affects F, but F is your main data structure, right? Because certainly if you have F, you can reconstruct and we have C, it never changes. Our CK plus K, that's stored in somewhere, that's global, that never changes. But as F changes, so F changes at different levels, and then we might have auxiliary tables that tell us about our partial solution method, but if we don't, then at least that's one of the obvious characteristics about F at different levels, is that it's got more entries filled in, and is that maybe that's the main abstract property of it. If I go down a further level, this means that F has more slots that are known,
more constrained,
but doesn't have any previously known slots are changed. In order to change a slot in F, in order to change F of 28, I would have to come back to a position where F of 28 was not defined and then move forward. But there's no, whenever I move down, I never negate any of the previous F's of F values. I never change any of the values that were known. I only make it more known. What is the word? Only refine the function or whatever it is.
There's a problem there in that if you find out that, say you try to put a certain letter in a certain place, and so you find out that F of 28 has to be 135.
Right.
You also get that F of 135 has to be 28.
Mm-hmm.
So that much can be easily undone. But suppose that when you find out that F of 28 has to be 135, you've got some other number, say 67, which you knew before could either be 135 or 182.
Right.
And
so this is not forcing
28
that
goes
one.
to 135 means that 67 has to go to 132.
Mm-hmm.
Instead, if you like, you've wiped out all of the possibilities for another number except for one, then you have to bind that one as well. And then when you go to undo 28, then you've got to know enough to undo 67.
And put back the possibility that you had for it.
Right.
Okay.
Put it back in every place.
In every place. So when you're making a logical deduction, then you have to have some kind of a backing up table that says this was deduced from that. If I take this one back, I got to take all these back too. Is that what you're saying?
Yeah, well, I'm not advocating this.
Not advocating it, but you're mentioning it. Yeah.
I think moving
Takes
the
too much
forward.
information to store at each level, though.
Yeah, it's a mess. I mean, it's a lot easier to move in the forward direction by storing one or more checkpoints.
Okay, so in other words, when you would have checkpoints at let's take suppose you took it at every even numbered level, for example, instead of at every level where you store the whole works, and then if you wanted to go back from level 6 to level 5, you could go back to level 4 and forward 1 to 5. That's what you're saying.
The trade-off would be, as usual, time for space. If you want to store every state, then you can backtrack really fast. If you want to, if you just want to store the initial state, it'll take a long time to recreate the previous state.
This is going to be an issue in problem 3 also, and in any kind of a thing where, or possibly in problem 3, I think. Anyway, so one of the ways of attacking problem 3 would be to have some kind of a method that's backtracking and undoing consequences of previous logical decisions. It seems to be important in lots of heuristic search activity.
What if you want to go to a state, that you haven't been to? I mean, it seems like we might have a state space graph instead of tree, because suppose if you don't undo things in the order that you did them, like you add F, add G, add H, then you want to take out F. Then you're to a state where you had G and H in a certain place,
Okay, yeah,
not F, which you haven't been to before.
Yeah, that's an interesting point that I found that when I was solving my own thing, I ran my program 5 times, as it turned out. I started out and I would go for ways and I would get more and more deductions and so on. But then all of a sudden I knew that there was some problem in my partial solution. But I had made, maybe at the second level I made a bad choice. But I went and made 10 good choices after that, and started to see that there's a word significant or something popping into my plain text, and so I knew that it was significant, except that it actually, what popped into my plain text was significext or something, something that I knew the real word was significant, but the reason that X was there was because of a bad decision I made F long ago, at a previous level. And so I would get to a point where I was getting big pieces of the message, but I also had glommed onto things I shouldn't have. Then I would stop and start over again. But my first guess as to a word to put in would be, some 50 long character string that I was sure was there.
Yeah, with my program you can recover from that sort of mistake because you can change single letters. You say, in your example, if you had significant or something like that turn up, you'd say, okay, I want to undo that letter, and then you could go back and put another letter in there.
Okay, so that says that you then are updating your F somehow
That's right.
based on the visual on what was displayed. And somebody could say change that to that X to an N.
Well,
what else gets? In other words, there might be some other letters in there.
Yes, it would make other changes, but
how would it know? That's my question. See, how would it know what?
I don't store
you're saying change this letter X to an N, no matter what other, and anything else that's inconsistent with it, overrule that too. Is that what you're saying?
Well, it's actually done in two steps. The first step is you undo that particular map, which is which is okay. I mean, you can undo. You can undo that particular.
The X was sitting there because F of.
That's right.
Of something, F of 2 is equal to 3. Okay.
Right. Then the next thing you do is to say, okay, add the correct character in that place.
Okay, and
that would check for conflicts and stuff like that. Okay.
And if so?
And if so, it wouldn't let you add it.
It wouldn't let me change the X to an N because there would be another conflict.
Yeah. So you may have to undo other things.
It would tell you where that conflict was?
The sort of conflict you would get is something. The sort of conflict I detect is kind of conflicts where you've got a character which you're not allowed, a non-print, one of the characters which is not valid ASCII, not visible.
Yeah.
If that character was going to turn up, it means that particular map would have been wrong, surely.
Well, maybe, but the X was wrong too, is what I meant. So maybe I had two errors.
It should have been moved along one, or.
Yeah, it's getting to see if there's some other. If I knew the X should be an N, but this machine isn't going to let me change the X to an N because this would mean something. Let me see. Does that ever arise? Maybe it doesn't. It can't happen because the only thing that's happening when maybe it can. Let's see. Go back again. To change an X to an N, you say it takes two stages. First, I undefine the reason why the X appeared.
Right.
Undefining is always harmless. It can't introduce any new contradictions.
That's right.
but then putting the X, putting an N in there, now what I'm wondering is, could it lead to a contradiction that's only a contradiction because of something, some other assumption that I made?
Perhaps, yeah.
Actually, even unbinding something can very occasionally lead to a contradiction if
you're using if you're using problem solving that uses the pigeonhole principle as well.
Right. My program doesn't use that, and so I'm not going to have that problem. But I may have other problems. Well, you just have to. You'd have to. No, at the moment it doesn't tell you where the conflict is. So perhaps I should change my program so it tells you where the conflict is, so you can undo something further if you thought that was necessary.
I still don't see what kind of conflict that could be.
Yeah, well, let's try to see if, because I do remember vaguely when I was writing my program, there was one simplification, say, oh yes, this kind of thing can't mess me up, but I don't remember what it was. Well, let's see if I can go. Let's see if we can think of a scenario. Could this happen? So I'm sitting here and I found the word significatext, and all of a sudden I realized that that's probably an N, right? This is what we're getting at. Okay, so I want to undefine this first of all. Yeah, thanks. I want to undefine this and now, in this first step, Roger is saying that this might also lead to something because he made the fact that X was okay. So the fact that this X was there was because f of 2 was equal to 3 and f of 3 was equal to 2. For example, let's say I'm going to get some concrete numbers in here, and so by undefining the fact that I had an X in here. maybe that just says that f of 2 is now undefined and f of 3 is now undefined.
It can't be a contradiction because there's always something that satisfies it, namely what you just had there.
No, but if you had, say, if you had f of 2 narrowed down to, I mean, let's see.
F of 2 was narrowed, f of 3, f of...
Whenever you remove the constraint, you just, whatever you then have will include what you just had.
You've still got constraints though on the f's by what, like say if you've got a certain, if 2 appears at this point in the message and appears at this point in the message, and you know that they both have to translate to visible characters in both places, then you know that f of 2 has to map to some number between say 63 and 67.
Or 3. Or 63 to 67. Is what you said there.
Right.
Yeah, right.
And, well, basically either you could find, either that could be even narrower where you just know that it has to map to 3, or there could be something else that's down to that narrow range.
If it was only 3, then of course it's going to be a little hard to undo this. But it was only 3 because of other things in the message. I mean, the reason that this other 63, 67 was currently eliminated was because there's something else happened in the message this wasn't my only error in the message. Maybe I've got a bunch of other F's are also wrong. And so the fact that, but whenever, so for example, suppose somebody had, I'm not sure this is going to leave me. If f of 63, let's make it just 3 or 63 to make it simple. Suppose that that f of 63 was I don't know what? 42. 42. All right. Goodbye that. F of 42 is 63. Okay. Now, so then this possibility wouldn't appear in our data set anymore. It would look like f of 2 couldn't, had to be 3 or nothing. And so really by
your data structure is set up.
Yeah. So he was using a forcing table that would say that as soon as you get to a row that has only one possible position left, he jumps to that conclusion that it has to be that other position. Before that, before f of 63 was put in, so f of 63 was filled in, that took away f of 2 and forced f of 2 to be there and forced us to get an x in the message. Now when we take that x out, somehow we've got to know to take out f of 63, which is somewhere else in the message. This is, I guess, the issue then.
The way we do it is we keep around the illegal possibilities also, and just have them flagged as illegal. So when you back up, you can actually remove the flag.
A flag is
well, in some sense, we have another list that has other information to keep it to say which ones are legal and illegal of the possibility.
Okay, so you have a sort of the level 0 implications of the whole thing, where in other words before any other assumptions have been made, at least you know that f of 2 could only be such and such, and then there are other higher level implications that have been made, that have been put on top of that.
So you would have 3 and 63 in there and somehow mark that 63 is no good at the moment.
Not at the moment, okay.
And if you back up, then you could reawaken that. And we also have the possibility that you can commit yourself, that is, say that store these, because it does take a little bit longer with all these possibilities. And so you could actually change the table and start from there. Then you couldn't back up over that unless you recomputed the whole table.
Okay, and recompute the whole table means of all the
possibilities,
the new possibilities, and so and so that's a that's the other issue that came up. Suppose that I say, after I've undefined this, now I want to put an n in here. Now putting an n in here might now be saying f of 2 is 63, and that would mean that f of 63 is now 2 instead of 42, and I'm going to have to change something else, and this is Kathy was realizing might not allow me to change this to an n, because there's somewhere a conflict elsewhere in the message, but it wouldn't tell me what the other conflict was, and so it would have to. So the fact that this would change to another one would really, undefine f of 42 and change this to a 2 as well. That depending on how much deduction you're doing in your data, this undefining wouldn't be a problem, but if you're doing a lot of deduction, you have to take account of every undefining step as well as every defining step. And so that would lead to a conflict, saying you can't change this to an n unless you change this to a 3 over here or something like that, and then the user should be able to say, okay, do that too. Or you should be able to say, I know this is an n. Anything that it conflicts with, remove that too. It's sort of, don't tolerate any dissension. Okay. Now let's see. What groups haven't I heard from yet? Andy, you working with?
Mike.
With Mike. Okay. Roger, who are you working with?
Working with Neil.
And that leaves John. You're with Rich and Karen. Amy.
Andy Tucker.
Okay, you and Andy?
And John.
And John, okay. That's a complete set, okay. So let me see, what else can we talk about here? What issues are there in your approach?
So far?
Yeah.
Comps.
Comps, okay. So, okay, that's fine. 2 minutes on comps. Okay. Well, let me just say that on Tuesday we'll want to see how much progress we're going to have into getting the results of online computations into our class, so that week from Tuesday everything will work smoothly. But what is it going to be like a week from Tuesday? Well, I somehow have this vision that you might have a better idea for, but tentatively, it's going to. I think we'll try to use everybody's program to do part of the job. In other words, we'll log into one system, we choose at random, and we see if we can get some advances into the cipher. Then we stop there and start on somebody else's program, but with another plausible keyword. Maybe this isn't fair to, it's not symmetrical, but I don't think we can really have 5 groups all working on the just against time to see who's going to solve it first, and then have a play-by-play coming over here and say, okay, in this group here, I'm not sure how many modems we need, but but then nobody else. I guess everybody else could watch it on videotape afterwards and see what the other groups were. Huh? All right. Okay. Well, I've got my assistant here to help me with the commentary on the for color, and we can do instant replay. What?
We were envisioning a tournament style. But,
yeah. So, okay. Well, if you want to try to imagine something like that, you can do that too. I was just wondering if we could all work as, somebody would say, oh, I bet you that word is cryptogram or something, and then we'll try that, and nope, doesn't work. Well, we can still design what the final demonstration day event is. The main thing I want to make sure is that we get to see everybody's program in operation on that day somehow. That's an absolute deadline.
What type of terminal will you have to make sure it works?
Well, that's the kind of issues that we need. Okay. Okay. Thanks a lot. I'll see you on Tuesday.